today we are talking about what is called the Extreme Value Theorem. And the Extreme Value Theorem is coupled with the study of absolute maxes and mins. On the formula quiz you just got back, there was a question about the intermediate value theorem, and you had to put the word intermediate in the blank. Now you have a new value theorem, the extreme value theorem, and you need to be able to tell the two of them apart. Okay, there's also a mean value theorem, so there's going to be 3 when we're done. And that's coming up later this week. The extreme value theorem, though, is rather easy. What we are about to start studying is how to find maxes and mins of non-parabolas without a calculator. So you've been doing maxes and mins since Algebra 2. You've taken parabolas, found the maximum point. You've taken the calculator, found the maximum point with the calculator. We're going to learn how to do it with parabolas and non-parabolas with and without a calculator. It can all be done with calculus. But today is the foundation for that, dealing with what's called the extreme value theorem. Now, this is used on what we call a closed interval, which is written bracket A, comma B, bracket. And once I talk about what the extreme value theorem says, it will make sense why it has to be closed. Okay? I'm going to go ahead and write it out as it's written in the book because it's actually one of the easiest ones to understand, even in its mathematical terms. The extreme value theorem is as follows. And you can call it EVT if you want to. It says, if f is continuous on a closed interval, bracket A, comma B, bracket, and then a comma afterwards. And I'll wait for you to catch up. If f is continuous on a closed interval from A to B, then f has both a maximum value and a minimum value on the interval. Then f has both a maximum value and a minimum value on the interval. Now raise your hand if you think that makes sense to you. 2 or 3 of you, not very many. Okay, picture's worth 1,000 words. Draw a first quadrant for me, just like so. Put an A and a B on the x-axis because they are x values. Now, anywhere you want to, I want you to put an endpoint for A and an endpoint for B. Basically, a dot here, dot there. It doesn't have to be B, doesn't have to be higher than A. A could be the same. They both have different y values, and they're closed circles because it's a closed interval. Okay? Now, whatever you have on your paper, I want you to draw a continuous curve from A to B. Continuous as in, don't lift your pencil. No holes, no asymptotes. Just draw a function that connects A to B. Anything you want, as long as it's a function. There's my function. Try to be weird. Okay. According to the theorem, if f is continuous on the closed interval from A to B, that's a continuous graph, and so is yours, there has to be a maximum value and a minimum value on your graph. Do you have a highest point on your graph? Is there a highest point somewhere? Is there a lowest point somewhere? That's what the extreme value theorem says. So as long as your interval is closed, you're going to have a highest point and a lowest point. Now, do any of you have a multiple high or low point? The same high point twice or the same low point twice? Anybody? A couple of people shaking your heads. That can happen, can't it? On a sine wave. Think about a sine wave. If you go like in one period of a sine wave, don't you have a couple of high points and a couple of low points that are the same? Yes.
What if it's like a flat?
Then they're all the max and they're all the min. Okay? So, before I write the rest of this, are any of your high or low points the end points? Did that happen to anybody? So that can happen as well. The max or min can be the endpoints or in the interior. And the second thing that we noticed is that maxes and mins can be at multiple points. So you could have the same point twice as a maximum. Okay. In calculus, there are two types of maximum and minimum points, and we're focusing on specifically one of them today, and it says it in the title. It is absolute maxes and mins. Absolute. That's just cut, dry, gonna happen, no questions about it. It is the very highest / lowest point. No doubt about it. Every closed interval will have an absolute max and an absolute min. That's what the extreme value theorem says. There will be a highest point, there will be a lowest point. Okay? However, on my picture specifically, there are maxes and mins within the middle that are not the highest. And these are called local or relative maxes and mins. And we need to address that as well. Local or relative maxes and mins. They are the highest or the lowest point, quote unquote, in the neighborhood. Okay. As you write that down, I want to kind of give you a mental example of what I'm talking about. The highest or lowest point in the neighborhood. Okay, since I'm talking about neighborhoods, let's talk about a neighborhood around here. One of the reasons I am glad that I moved to San Antonio from the Dallas-Fort Worth area was because Dallas-Fort Worth, if you've ever been there, is flat. There is no character at all to the landscape. It's boring. It's flat and it's all concrete. At least down here they know how to build houses and actually give them character and not mow all the trees down before they build houses. So, all of you in here, I'm pretty sure, drive or have driven around here. Picture yourself driving on Knight's Cross coming from Bush to Reagan. Okay? Some of you may drive that route every day, but you know what I'm talking about. Picture yourself driving from Bush to Reagan on Knight's Cross, okay? There is a certain point as you're driving along, because I used to do this 2 years ago. My son was at Bush. I had to do that every day, drop him off at Books, come over here. There's a certain point as you're driving along where you get to this point and all of a sudden you can see for miles. You know what I'm talking about? It's kind of like the top of a hill and all of a sudden you can just see forever out down towards Knight's Cross. That right there is a local maximum point. It is the highest point in its neighborhood, but is it the highest point in the world? No. But it's the highest point in that area because you can see so far. So that's what I'm talking about. Yes?
So it's kind of like just the highest and lowest point in a given interval?
In a given interval, exactly. For example, this right here, that's a local maximum. Because of the points that are kind of on either side of it, it is the highest point. That right there is a local minimum because on the points around it, it's the lowest point. Okay? So we're going to talk about how to find these things and then how it applies to finding absolute maxes and mins. Okay, now, I'm going to have you draw this rather large picture. I want you to do the best you can. Let me finish it first. This is a curve. I want you to start down here, and I want you to do kind of a thing like this and come up like that. And then I want you to come down like that. See if you can draw that. Something like that. And it's like, what did you do, Miss Bell? Okay. This is a pretend graph that we just made. Okay. This point here, the starting point has got to be lower than the ending point. Okay. To match mine. Now remember I said local maxes and mins have to do with points in the neighborhood. How many local minimums do you see? I see 3. Where's the first one? At the starting point, exactly. So put a dot right there and label it the local minimum. Okay. The next one, as you travel the path, is right about here. Local minimum. And where's the final one? At the end. Put a dot right there, local minimum. Okay, how many local maximums do you see? I see 2. The first one is about right here. Local maximum. Okay. And the other one is up here. What kind of point did we call that again? We gave it a name a few weeks ago. It's a cusp. Very good. This is a local maximum. Okay? Now, did I draw a closed interval?
Yes.
Yes. It starts here, stops here. It's closed. Therefore, there must be a very highest point and a very, very lowest point. Which one is the very highest point? The cusp. So it's also, this local maximum is also the absolute maximum. Okay. Where is the very lowest point? The beginning. So this is also the absolute minimum. Okay? So, when you're doing these problems, you're not going to be given a graph. You're going to be given an equation. And from that equation, you're going to pull out all of the possible maxes and mins. The absolute max and min has to be a local max or min first. Does that make sense? It has to be the highest or lowest point first. So you're going to pull out all of these from the equation and then figure out which one is the highest and which one's the lowest. Kind of like the election. Okay? Tomorrow's the big day, right? In my house, it's not as big a deal as election day. It's my son's birthday tomorrow. He's turning 16, so it's like that's election day. He wants his candidate to win. But anyway, but the point is, when we started the election process, we had a huge pool of candidates, didn't we? More on the Republican side than the Democrat side. But all these people wanted to run for president. They were all candidates. These are all candidates for the max and the min. Okay? And just like one person ended up being the Democratic candidate and one person ended up being the Republican candidate, one ends up being the absolute min, one ends up being the absolute max. Does that make sense? So, okay. The set of all local max and mins have some unusual names that I need to give you, that you need to be familiar with. There are 2 phrases that define the set of all the local maxes and mins. In other words, all these points. In some problems, they are called critical points. The directions may say, find all the critical points. That means find all the all the local maxes and mins. And the second one is relative extrema. Relative as in the word relative max or min, and extrema means maxes and mins altogether. Okay? So both of those phrases mean all those points. Okay? Now, all 5 of these points have one of 3 characteristics. And so basically, just like when you're running for president, there are certain characteristics that have to be in place. Those of you who are in government right now, you've talked about this already because my first period knew about it. What's one of the things that you must criteria in order to be a candidate for president?
Born in the U.S.
Born in the U.S. is one of them. What's another one?
35.
35 at least years old.
14 years citizen.
And you have to be,
A citizen for 14 years.
no, you have to,
Resident.
resident for 14 years. I thought there was a third one. That was the third one. There are actually 3 criteria for these as well. So we're going to talk about that. So in order to be a candidate for a max or min, here are the criteria for max and min. And it doesn't, unlike the president, you don't have to have all 3. It's one of the 3. Criteria number 1. And it happens to apply to these 2 points right here. These 2 points have the same derivative. Can anybody tell me what the derivative at those 2 points are? 0. If the derivative is 0, you're either hitting the top of a hill or the bottom of a valley. Okay? So criteria number 1, in order to be a candidate, your derivative could be 0. Your derivative could be 0. Okay? Criteria number 2 applies to the cusp. The derivative is not 0 there. It is not differentiable at that point. The slope coming in this way and the slope coming in this way are 2 different slopes. So it is basically what we call the derivative fails. Or you can also call it a DNE. The derivative is a DNE. It does not exist. If you want to think of it in terms of tangent lines, I could draw 1,000 tangent lines right there. That's why the derivative fails there. I don't have one distinct tangent line. Now, what 2 points haven't I talked about? This one and this one. And we call those the endpoints. So the endpoints could be the maxes and mins. You need to memorize this right here. The 3 criteria for being a max or min is it's one or any one of these. The derivative could equal 0, or the derivative could fail, or the endpoints. And that creates the candidate pool, those 3 criteria. Then from those, we figure out which one is the highest and which one is the lowest. We could tell by looking at it here. Now we're going to learn how to do it with an equation, not looking at a picture. Okay? So, 3 criteria. Keep that in mind. We're going to do a couple of examples because they do take a little bit of paper. Is everybody done with this page? Okay, next page for me. For example, f of x equals 3x squared minus 24x minus 1 on the interval from -1 to 5. This time, we're doing it with no picture. No picture. Okay, let me write down the way the directions are going to look. They will say, find all relative extrema and determine the absolute max / min, period. Find all relative extrema and determine the absolute max and min. All right. So what we do, start going through the criteria. What was criteria number 1? What was at the bottom of the last page? Derivative equals 0. That's criteria number 1. So, no more e's, no more ln's for a while. We're just going to have simple problems to take the derivative of. So f prime of x equals derivative of 3x squared. 6x minus 24 plus 0. Set it equal to 0. Set the derivative equal to 0. Solve for x. So 6x equals 24. X equals 4. There's our first candidate for the absolute max and min. Step 2. After derivative equals 0, we're going to talk about derivative failing. Question mark. Now the reason it's question mark is because 98% of the time it's not going to. But you have to check and see. Okay? Derivative fails is a cusp, a hole, a asymptote, vertical tangent, something like that. Now, look at this graph. Yes? Sharp corner 2. Yes. Look at this equation. What kind of graph is this? It's a parabola. Do parabolas have sharp corners, cusps, vertical asymptotes, anything like that? No. So, they're pretty generic, so the derivative fails never on this graph. Now, what if it's an equation that you don't know what it looks like? Here's how you can tell if the derivative is going to fail. The only time it will ever fail is if you have a denominator with an x in it. Okay? So if you ever have a denominator with an x in it, it's going to fail, or it might fail. Okay, so I'm going to write no x's in the denominator to remind you that when you see an x in the denominator, you got to check it. Criteria number 3. What's the third possible one? Endpoints. Well, that's really the hardest thing on the page because all you got to do is look up here at the interval and write them down. X equals -1, X equals 5. God, that was hard. So, how many candidates do we have? We have 3. One of them is the max, one of them is the min. Absolute max and min. How are we going to find out which one is?
Plug it in.
Plug it in. Plug it into the original, see which one has the biggest y value and which one has the smallest y value. So, let me write that down. Plug each of the relative extrema, which is what we just found, into the original equation. Now remember, it's got to be the original. That's the problem. Don't plug it in the derivative. To find the absolute max and min. So after you've found your 3 candidates, just take each, or however many candidates you've got, you take each of those candidates, plug them into the original equation, see which one gives you the highest and the lowest y value. So we have -1 comma something, 4 comma something, 5 comma something. Now, this is no calculator, so you're going to have to do some number crunching. Some of you, this is easy. For me, it's not so easy. I'm not a real good number cruncher in my head, but I got a cheat sheet up here, so I'll try to not look at it. So we're going back to the original, whoops, took it off the screen, the original equation plugging in -1. So 3 times -1 squared minus 24 times -1 minus 1. Not exactly. Okay, -1 squared first is 1. So mark that out, put a 1. 3 times 1 is 3. -24 times -1 is positive 24 minus 1. 3 plus 24 is 27. Minus 1 is 26. Okay. So now we do 4. 3 times 4 squared minus 24 times 4 minus 1. Remember, you square before you multiply. 4 squared is what? 16 times 3 happens to be 48. 24 times 4 is -96 minus 1. 48 minus 96 is -48. Minus 1 is -49. It's going to take you a little longer. I understand that. So now we do the 5. 3 times 5 squared minus 24 times 5 minus 1 equals. 5 squared is 25 times 3 is 75. 24 times 5 is 120 minus 1. 45 minus 1 is 46. -46. Okay. Now, on these questions, they are going to ask you one of two things. They're either going to ask you for the coordinates of the absolute max, or they're going to ask you for the absolute maximum value. The absolute maximum is which of the two coordinates, if I was asking for the coordinates? -1 comma 26, semicolon. Now I'm going to write both answers down here so you know what I want. The absolute maximum value, and the word value in calculus every time means the same thing, is the y. So the absolute maximum value on this interval is 26. The absolute minimum is which coordinates? 4, -49, semicolon. The absolute minimum value is -49. Now, am I going to ask you for both? No, it's going to be one or the other. But for this problem, I wanted to write both of them down, just so you can see what I'm looking at. So look at the back of the answer sheet if it's not real clear which one they want, whether it's the coordinates or the value. Okay? Any questions? Okay, let's do the next example. F of x equals the cube root of x times negative x minus 16 on the interval from negative 8 to positive 8. F of x equals the cube root of x times negative x minus 16 on the interval from negative 8 to positive 8. Okay. So, I know in a minute I'm going to have to take the derivative. Does this one need any work to clean it up to make the derivative a little bit easier? Yeah, let's do that. X to the what power? 1/3, parentheses, negative x minus 16. Okay, now we go through the three-step process. Step 1, find the derivative and set it equal to 0. Do I need to pay attention to any rules as I do this derivative? Product rule is correct. So I'm going to give you about 45 seconds. I want you to do just the first step of the product rule. Don't try to clean it up. Just do the 1d2 plus 2d1. When you're done, look up here and see if you got what I got. I'll call it out for those of you who makes it easier. X to the 1/3 times negative 1 plus negative x minus 16 times 1/3 x to the negative 2/3. Are we good? Okay. Now, we're supposed to set this equal to 0. And I don't think you've ever done a problem like this, because this is pretty ugly. All right? So here's what we're going to do. We're going to clean it up and we're going to put it back into radicals. And I think it makes it a little bit easier. X to the 1/3 is the cube root of x times negative 1. Just put a negative in the front of it. Plus. So I'm looking at the second part of the problem. I see an x with a negative exponent. Okay? Which means it's going where? On the bottom. So I'm going to put a line. And I'm going to put it on the bottom in a minute. Where does the negative x minus 16 go? That goes on top. So negative x minus 16 goes on top. The 1/3, the 1 is the coefficient in front of this. So I'm not even going to write it down. But the 3 goes down there. And then let's put this back into its radical. That's going to be squared and a cube root equals 0. All right. Now what? There's a couple ways you can do this. And they're both equally challenging. I'm not going to say difficult. They're challenging. Okay? Some people say, well, just set the top equal to 0. Yes, that's true, but we can't do it until it's all one fraction. That's the key phrase, all one fraction. How do I make that all one fraction? I smile it, okay? So, honestly, smiling this is not going to be too bad because, look, you're multiplying radical to radical, which is not that bad. And then we're going this way. All right? Now, here's what we're going to do. We're going to do this multiplication out to the side. We have the negative cube root of x times 3 cube roots of x squared. So I have a negative times a 3, that's negative 3, and then multiply the radicals together. What is the cube root of x times the cube root of x to the second? The cube root of x to the third, right? And what does the cube root of x to the third equal? X. Oh, no more radicals, thank you. So this times this is negative 3x, that goes there, plus 1 times the negative x minus 16 is negative x minus 16 over the denominators multiplied together, which would be 3 cube roots of x squared equals 0. Okay, let's clean up the top a little bit more. Negative 3x plus negative x is negative 4x minus 16 over 3 cube roots of x squared equals 0. Okay, that looks a lot better. So if I'm setting the derivative equal to 0, Is that the top or the bottom or both? What do you think? It is the top, because setting the bottom equal to 0 is not going to give me a 0 answer. Another thing you can do is just put that over 1 and cross multiply, and that'll show you it's just the top. So now I'm just going to take the top off, negative 4x minus equals 0. Now I can solve that for x pretty easily. Negative 4x equals positive 16, x equals negative 4. Don't box it yet. Is it on the interval? Yes. Now we can box it. I'm sorry? If it's not on the interval, you cross it out and you just write not on interval. Okay? And you have one less point to worry about. Yes, sir?
Well, can you explain why it's only the top?
Because if I were to put this over 1, because 0 over 1 is 0, right? If you cross multiply, you'll get negative 4x minus 16 equals 0 times the denominator, which is 0. So the denominator goes away. Does that make sense? Okay. All right. So we've got our first critical point. Derivative equals 0. Step 1 is always the longest. I'm just telling you right now. Okay? To save space, I'm going to do step 2 over here. I'm going to kind of make a little squiggle. Derivative fails, question mark. All right. Where do I go look? I go look right as I'm setting it equal to 0. Okay? And we said that it would be a yes, the derivative might fail, if there's a denominator in our derivative. Is there a denominator here? Yes. So, when the derivative fails, you're supposed to take that denominator, 3 cube roots of x squared, and set it equal to 0. And now back into your question, that's why we don't set the bottom equal to 0, because that's actually step 2. Okay? So, some of you I know can just look at that and already know what the answer is, what x equals. Am I right? Yes? For those of you who are like, I have no clue. Do the math. Step 1, divide by 3. Cube root of x squared equals 0 divided by 3 is 0. Now I could keep going, but I'm going to show you, you can do this in your head. The cube root of what number is 0? 0. X equals 0. Is 0 on the interval? Yes. Box it in as well. I know I did it in red. That's okay. Okay. So there's derivative fails. Step 3, endpoints. Like I said, this is the no-brainer. X equals negative 8. X equals positive 8. Box them in. And we now have our 4 points to test to see which one is the absolute maxes and mins. Okay? So far, so good. Do you see how much longer step 1 took than the rest? It always works that way. All right, so now it's going to the ordered pairs. Negative 4, comma, 0, comma, negative 8, comma, and 8, comma. Okay. When I made this problem up this morning, I tried to make it come out pretty. I had a sign mistake in my work, so it doesn't come out pretty. This is one that you would actually need a calculator for to do the first one, but the other 3 you can do by hand. So I'm just going to tell you what the answer is. Now, which equation are we plugging into again, the original or the derivative? The original equation, because we're looking for points. So it's going to be the cube root of negative 4 times negative 4 minus 16. Move this up just a little bit. The one thing you cannot do in your head is the cube root of negative 4. And I will just tell you that the answer to this with a 4-function calculator is 19.049. Actually, you couldn't do this on a 4-function calculator. You could do it on a scientific. The other 3 you can do without a calculator. It may take a little brain work, but you can do it. Cube root of 0, negative 0 minus 16. What is the cube root of 0? 0. 0 times anything is 0. That one's done. Are you with me? Okay, let's write out the next one. Cube root negative 8. Negative 8 minus 16. What is the cube root of negative 8? Negative 2 times plus 8 minus 16 is negative 8. That's positive 16. And now for the last one, the cube root of 8 times negative 8 minus 16. So cube root of 8 is 2. Negative 8 minus 16 is negative 24. That's negative 48. Are we good so far? Okay, right now I want you to write down what the absolute maximum value and the absolute minimum value are. That's what this question is asking. So, absolute maximum value is blank. Absolute minimum value is blank. When you're done, check with your neighbor and see if you wrote the same thing, because I need to know that you know what I mean by value. Okay, is that what you wrote? I do not want the ordered pairs in this instance. Okay? Now sometimes they'll actually say, where does the absolute value, if it says find the x coordinate, you just write the x. But if it says value, you write the y. Are there any questions?